Right, guys. So today we would be talking about computer languages, algorithms, and program development. In the previous three lectures, we learned about different components of computers and how do computer transform or different kind of information into binary codes, why we use binary codes, and all that basic stuff. So we'll learn about all those things. Now, in this chapter, we're gonna learn about computer languages. In order to communicate with computers, we need to understand computer languages as if if you were to talk to someone who understand Russian, let's suppose, then you need to understand Russian language in order to communicate with that person. If that person don't know your language or you don't know his language or her language, okay? So, in order to communicate with, in order to make a computer perform different actions, not just to communicate, but in order to make the computer work in a certain way, based on your requirements, programmatically speaking. Let's say you want to perform some kind of actions through some applications, then you need to understand some programming languages which your computer understand in order to make that possible. Okay, so therefore we need computer languages. We'll talk about that, algorithms and program development. The main question which you need to ask yourself here is that how do computers know what we want them to do? How do computers come to the conclusion that whenever we instruct them to perform certain actions, let's say whenever we click on the word processor, like Word, Microsoft Word or MS Word, why do how do computer know that I need to open this beautiful application, and then if the user type in something, I need to show that to the user. How do computer understand that? So we need to ask that question, and in this whole lecture, we'll try to understand uh, the things around this question. Okay, so we'll try to understand this question as a whole in this lecture. Now, in this chapter, we will try to understand what makes up a language and how do we use language to communicate with each other and with computers. How did computer programming languages evolve, and how do computers understand what we are telling them to do? What are the steps involved in building a program, and how can we create something that would be visible on www or w, okay, which is World Wide Web? How uh, can we create something which will be visible on the internet? As simple as that. It's referring to web applications, websites are simply. So we'll understand these things here. Now, a common cycle of communication with a computer is like there is an idea to be sent. Let's say you want to send something uh, through a computer. That's an idea, okay? So you need to send an idea, and there's an encoder which encodes your uh, your idea, and then send it, okay, through a certain medium. That medium could be wireless medium, and the medium could also be wired medium, depending on whatever medium of communication you are using. And then there's, on the other hand, there's a receiver device. Okay, let's say you are sending some messages on WhatsApp to your friend. There's an idea. Let's say you want your friend to uh, come for lunch. Okay, you just, that's an idea. You send you wrote that, and whenever you wrote that, it's encoded into another things. Like there are various other in the encoder itself. There are so many things which you can learn. For now, just for simplicity, we would just name it as encoder. You encode that information into another form. in a form of bits, and then you attach different sort of networking related stuff with it, and then send it through a medium. Okay, so in the encoder itself there are lots of things. I'm just giving you overview that it's just, you're encoding something, you're changing it to another form. You're let's say that your message or idea was a text form, like, right, you wrote it and then it's encoded into binary format. Okay, and that is sent, or uh, then you are the sender. Now you're the sender and you're sending the message. You send the messages, and it's going through a medium. Like, you send it, you're connected to a Wi-Fi, which you're connected to your Wi-Fi wirelessly. Again, that your Wi-Fi is connected to your internet service provider (ISP), which is again a very heavy term for now, but you will understand that later. What is ISP? ISP is basically the company which provides you services you provide you service. Like in our case, we have not Naptel, but we have ITEL, and these sort of are PTCL. So these are who provide are the ISP providers. Okay, now uh, you are sending that through a medium, a wired medium, okay, that is provided to you by the ISP providers. Now your friend is in another country. Let's suppose your friend is in Dubai. Okay, now that messages is being sent to the person, to the ISP provider in Dubai, through a medium. The medium could be wired or wireless. Okay, and then your friend is a receiver. He receives your message, and the receiver is not just it's not your friend in a sense. It's the mobile phone or the laptop of your friend, which is receiver. It receives the message and then it decode the message, transform it back into the text or whatever format you have sent it, and then you gets the response of that. Okay, so that's how a communication cycle works in computers. In a communication cycle, we are substituting the computer for one of the people. So the process is basically the same. Response maybe the symbols on the monitor. Okay, so uh, in the previous case, I was it's just in case of communication, or right, communication cycle, general communication cycles. Now, in case of computer, it could be a monitor instead of a person. Okay, that's what it tries to say. A breakdown can occur any place along the cycle between two people. The person can't hear you, the phone connection is broken, the middle call. One person speaks only French while the others it only Japanese, or one person speaks Urdu while the others don't understand Urdu. So that sort of stuff could happen, and that could break down the communication cycle. And in a similar case, between a person and a computer, the power could be suddenly interrupted of your computer, the internal wire become disconnected, and so many other cases could happen. Okay, so when communicating instructions to a computer, areas of difficulty are often part of encoding and decoding process. So it's just in a communicating process, the most difficult area are often encoding and decoding the messages which are being sent over the internet or whatever. So programming languages bridge the gap between human thought process and computer binary circuitry. All right. So, so here is the thing. Let's say you want, for a non-technical person, if you want to communicate over the using computers, it's not that difficult. You just pick up an application and you use it. Now, here, in order to make the computer able enough that could send a message whenever you type something, or send a video, or voice chat, in order to make that possible, in order to make their WhatsApp able to send the messages to other person on other side of the planet, that is the work of the programmers. Okay, that's what the programmers do, and there we need the programming languages. Programming languages bridge the gap between human thought process and computer binary circuitry. It bridges the gap between the human thought and computer circuit, in a sense that you write something in a programming language and computer understands that programming language and give you output as per you wrote the whatever instruction you gave to it. Okay, and programming languages is just a series of specifically defined commands designed by human programmers to give direction to digital computers. Okay, so commands are written as a set of instruction called programs. Our programming language instruction must be expressed in binary code before the computer can perform an action on them. So that's the simple thing, which I think you understand. So there are three fundamental elements of language that contribute to the success or failure of the communication cycle. Um, in any program languages, there could be semantic error, syntax, or participants. Okay, so these are the three things which are fundamental to the communication cycle uh, between any computers. Okay, so in order to communicate, the semantic, syntax, participant uh, all should be okay at the same time. Now, what is you might be asking, what is semantic? Okay, that's a kind of heavy word. Semantic refers to just meaning. You know, to see how this was accomplished, let's investigate how programming languages evolved. First, languages was machine code, then second generation language, assembly language code, then third, people-oriented programming languages, fourth, non-procedural languages, the languages which we have now, like Python, JavaScript, C++, and fifth generation languages, which is on its way, and it's in the progress, that a time will come that we no longer need any programming languages. We would be just talking in a natural language, and that would be uh, the computers would be able to transform that into any program, just like ChatGPT is being able to write any program based on the instruction we give it to. So that's how the fifth generation languages would work. Now, second generation, now first generation. Let's discuss a little more about first generation languages. So, first generations or obviously the machine language code. These programs were made up of instructions written in binary code. So that's also called a native language, and it uses two instruction part. Each instruction part has two parts. One is operation code, which is simply called as opcode, and the operands. The second thing is operand. So the opcode is the command part of computer instruction, and the operands is the address of a specific location uh, in a computer memory, on which the operation in the opcode need to be performed on. And it's a hardware dependent, could be performed only by one type of computer with a particular CPU. It was hardware dependent because based on the architecture of any CPU, the programming was, or the machine language, the programming of the machine language was different. It used to vary based on each machine. Then comes the second generation language, which is assembly language. So assembly language programs are made up of instructions written in mnemonics. So what actually is mnemonics? Mnemonics uses convenient alphabetic abbreviations to represent opcodes, okay, operation code, and abstract symbols to represent operands. Each instruction has two-part operation, code and operand. So it's hardware dependent again. And let's say you want to read something, instead of writing it in binary format, we represented the operation opcode uh, by read. Okay, in the backend side, in the foundation, it is just we are using our we are mapping the read to any binary number which actually reads some number. Okay, so that's how it works. And because and yeah, that's how it works. We do the same for load, aid, store, print, stop, and so on. And also, because programs are not written in ones and zero, the computer must first translate the program before it can be executed. So in order to run the assembly language code, we need assembler which could translate the assembly language code into binary code, so that they could be executable by the computer. Then comes third generation, which are called people-oriented programs as well. Uh, Here, instructions in these languages are called as statements, and these are also considered as high-level languages. Uses statements that resembles needed to express the problem or task being programmed. It's transportable. That was the main evolution made here. Here, the in third generation languages, it wasn't hardware dependent because the programs are not written in 1.0 again. They are not written in 1.0, so we need to translate them into executable binary format as well. For example, we have here Python, which is third generation. For example, we are reading two numbers, add them, and printing out. Here we just wrote a function by using the def keyword, and then sum2 is our functions taking two numbers, number 1 and number 2, and then calculating the sum, which is num1 plus num2, and then printing the sum. So that's an example of this. Then come the fourth generation languages. Okay, fourth generation or non-procedural languages. Uh, these are like programming. These are programming-like systems and are aimed to simplifying the programmer's task of imparting the instruction to the computer. Many are associated with specific application packages. For example, we have queued languages like SQL, and these are could be considered as fourth generation, or application generators. These are also considered as fourth generation. For example, the macros which we use in words and also our report writers. These sort of things are considered as fourth generation. All right, we have Kira languages. What does these things do? These things enable a person to specify exactly what information they require from the database. For example, I just gave you an example, a SQL an example of Kira languages. And then we have report writers, which takes information retrieved from the database and format it into attractive, usable output. If you have used any database system or DBMS system like Microsoft Access, and or so there are so many others, then you might have idea about how you can use during query languages, and also how you can create a report from by taking the information retrieved from the database in a very beautiful format. So that's also there. And then we have application generators, where a person can specify a problem, describe the desired result. For example, they can computer macros in Microsoft work, which where you can create a macros and macros for any frequently used application, and that would work that way. All right, then we have again there are two types of fourth generation languages. One is Non-procedural, which are these languages, query languages, and we have procedural languages, non-procedural languages as well. These are procedural and this is non-procedural. Um, so we have non-procedural here, which says object-oriented language, OOP, which is a language that expresses computer problem as a series of objects. A system contains the behavior of those objects and how they interact with each other. You learn about this in detail in your next if you're a university student, you will learn about OOP in your upcoming semesters. But for now, it is just representing any number based on its behavior and its characteristics. Okay, where the function represents the behavior and each characteristic is represented by some member, you know, member variables of any object. So you'd learn about classes and all these things later on. An object is a main character here. It is an entity contained within a system. For example, a window on your screen is an object. A list of names you wish to organize, an entity that's made of individual parts. I would give a simple example here that let's say you want to create an object of an animal. Okay, so for any kind of animal, there could be certain side of attributes, uh, certain type of characters. The animal could have name, the animal could have breed, or the animal could have certain characters. So based on that, you could create an object of that um, that thing, that object, or any animal. So some popular languages which offer OOPs are C++, Java, and Python. Java is no, is a famous non-procedural OOP. Is heavily is depend is made up of object type of language. It uses concept of OOP very heavily. Obviously, in Python we have the same in Python. Uh, and C++ in JavaScript, not in JavaScript, no, not so much in JavaScript, but you can use it. Then we have fifth generation AI and natural language processing, NLP. This is the fifth generation, okay? So it's modern AI enabled computer programming languages which enable people to understand and generate enable AI to generate human language through NLP. It basically help human to create programs using natural languages like the best example of virtual assistant examples would be virtual assistants like there are lots of virtual Alexa and so many other things, but there are also many generators which are also example of this, like ChatGPT, DeepSeek, and JTB Transformer. They could be an example of this. Okay, so that's the again the very important thing. While keep in mind that full natural language programming is still evolving, advancement in AI would bring us closer to seamless human-computer interaction. So that need to be happen in the future. All right, then assembled, compiled, or interpreted language. So there are basically three types of languages which could be assembled, then compiled. Compilation is a very different concept in itself. Assembling is in itself a different concept, and interpreting is also different languages, but they are doing the same job. They convert any programming languages into binary code. That's the job of these things. So let's see how they are different. So all program must be translated into computer understandable languages before the instructions can be executed, and computer languages can be grouped according to which translation process used to convert the instruction into binary code. So we could use assemblers, interpreters, and compilers for this purpose. So what are assembly languages? Now we come to the point that we here what are the languages which are assembled. Okay, so assembler is a program basically which is used to translate assembly language programs. Produces one line binary code per original program statement, and the entire program is assembled before the program is sent to the computer for execution. For example, you write something in assembly language. Okay, let's say you write something in assembly language, there is being converted through assembler. Okay, that's converted to binary code, executable code, uh, before that is being executed on a computer. Okay, and once the assembler does its job, when this job is done, it is being sent to the computer for execution. So that's how it works. Then comes interpreted languages. These are those languages which are being interpreted. Okay, so interpreter is basically a program used to translate high-level programs, translate one line of the binary into binary code at a time. So in case of assembler, what assembler does is it takes uh, the code, convert it to binary, and then uh, make it just a single string of binary code, and then computer execute it. While in case of interpreted, it interpret everything line by line. Okay, it translates into programming. It translates any program into computer understandable code line by line, and it fetch and the procedure for this is it fetches an instruction from original source code, then interpret, check every single instruction for any errors, and if found any error, it pass an error, and if the instruction is translated into binary, the binary code is then executed, and the fetch and execute process repeats until the whole code is being executed. So that's how it works. It is totally different than assembler. Then what assembler does was it first convert all the code into assembly language, sorry, in binary code, and then that was sent to the computer for execution. But in case of interpreted languages, it first fetch every line, execute it, and go to the next and so on. So the best example of this type of language is Python. Python is again an interpreted as well as compiled language. So keep that in mind. All right, so next we have compiled languages. So compilation is in itself a very broad topic, and you would study it a whole semester. Okay, a whole 6 months is dedicated in bachelor's program for this compiler construction. It's very interesting and very um, useful to understand this. So you'd learn that in that class, but for now I'll just give an overview of what is compiler. So compiler is a program used to translate high-level programs. It translates the entire program into binary code before anything is sent to the CPU for execution. And the translation process for a compiled program, first the compiler checks the entire program for syntax error in the original code. Next is translate all the instructions into binary code. Two versions of the same program exist: the original source code version, the binary code version, object code. Last, the CPU attempts execution after the programmer requests the program to be executed. Okay, so that's how it works. It basically takes the string of programming languages, whatever you wrote in the programming languages, then convert or translate into object code. In the middle, there's so much other happening in the middle as well. We would not talk about that because that would be really difficult to understand for now, because that's a sort of high level concept. You learn that in your next classes. Okay, so what it does is it translates the whole program into from the source code to object code, and then that object code is being transferred to the CPU for execution. So that's how it works. So programming for everyone, there are several ways you can control how your computer to perform tasks or accomplish this particular task. You can use macros, you can use HTML to create web pages. You could use scripting languages like Python or JavaScript, so for creating some applications, or Kotlin, maybe if you're a application developer, mobile application developer. So each allows customization of current application as well. Here you will learn about how you can use macros, which earlier we also mentioned in the lecture. So macros are just a set of operations within the computer application that have been recorded for later execution. So if you have ever used Microsoft Word, there's an option for macros. If you haven't done that, check that out as well, because that would make it clear for you how you can use macros. Okay. So once you by means of recording means you just automate some kind of action by telling it that if ever I ask you to do this thing, you need to perform this sort of task for me. So you record that and name it with a particular macro. Okay. Then when you click on that macro, it automatically performs that tasks. Okay, that's how it works. The macro can be used repeatedly on any document within the application, and in word processor, macros are commonly used to speed up repetitive tasks. Example, SIG or signature can be stored as a macro that includes signature message at the end of document. So that's an example of that, as I just mentioned. Then you can use HTML to create web pages. As you all know, that HTML is being used in the front end for just to create the skeleton of the application. So you could use that to create web pages. A computer language, HTML hypertext markup language, is a computer language. It consists of special code or tags intended to design the layout or markup of the web page. So web browsers interpret the HTML. Any web browser, like whatever you're using, whether you're using Brave, Chrome, or whatever. So they interpret the HTML code and display the resulting web pages. And web browsers, these are, if you are not familiar with web browsers, so web browsers are program that display information from the World Wide Web or www. And each line of HTML is called tag formatting instruction. So you learn about that. Yes, here we can see we have HTML tag, and inside the HTML tag we have heading tags. Inside the heading we have title. We could also link some external links in the heading here as well. And then we have body tag, and inside body tag we could have different paragraphs, we could have headings and so many other things. Okay, we could also link to some other external links as well. So that's how the HTML work. I am pretty sure that you must have, if you're a computer science student, you must have encountered HTML in your ICS classes in your high school. And then we have scripting languages. Scripting, it's a series of commands written to accomplish some task. So for front end, we always use HTML, CSS, and JavaScript, uh, or JavaScript for to do things dynamically and to perform some tasks there. But in the backend, we mostly use JavaScript, maybe Python. We could also use C++. We could use Java and so many other applications. But for now, we use different frameworks for writing code. We barely write in plain CSS and HTML. We use the React framework, which is also a very wonderful JavaScript framework. We use Node.js in the backend, which is a runtime for JavaScript, runtime from JavaScript. So that's how these scripting languages work. And JavaScript, as you can see here, is a scripting language that allows the page designer to add functionalities, features to a formatted web page created in HTML. So that's the short introduction to JavaScript. I'm pretty sure that if you are someone who wants to get into computer science or software engineering, IT, or many other tech-related fields, you must have encountered this in your learning journey. All right, building a program. So now this is a kind of software engineering perspective, which you need to understand here that whatever type of problem need to be solved, a careful thought of and thought out plan of take called algorithm is need to be before a computer solution could be determined. Okay, so in order to build any program or any application, we need to go through certain processes. We need to develop the algorithm, we need to write the program, we need to document the program, and we need to test and debug it. It goes same with the software engineering lifecycle. There are some other things. It goes up to 7, 8 more steps, but uh, but in the core, it's the same as this is. So how we could develop the algorithm? So what algorithm is? It's a just detailed description of the exact methods used for solving a particular problem. Okay, so it's in detail tells that what need to be done by the computer. So it's consists of a procedure of or a sequence of instructions, and it used to develop the algorithms. The programmer need to ask what data had to be fed into the computer, what information do we want to get out of the computer, and in the logic or business logic, you have to play is the planning of processing the program. It contains the instruction that calls the input data to be turned into desired output. So it is the best indeed when you are developing some algorithm. You need to ask yourself that what data or what input is going in and what it would give out of the it would give us output out of the program. So that's what you need to ask, and then you have to design your algorithms or your program accordingly. So again, if we explain the algorithm, how we can develop an algorithm, it's a step-by-step program and created during the planning stage, and there are three major planning detailed algorithms. We need to have flowchart, we could use UML diagrams, or we could use pseudocode. Okay, so flowchart is basically a visual representation of the logical flow of program, that what would happen if I go there, I go that, I go there, I go that, and that sort of things. And UML is sort of the same thing but with a different representation, and pseudocode is actually writing the algorithm in simple words. It's assured that we use verbal shorthand methods that closely resemble a programming language, but they don't follow any syntax or semantics. They don't really follow any programming syntax. So if you talk about flowchart, here's the flowchart. Let's say we want to go out somewhere. Okay, so for that we start, then we count the money. If the count if the money is greater than, let's say, thousands, if the money is less than $10, then you cannot go out. Do you have more money than $10? If yes, then you can go out, and then come back and you can count your money. And if you have $10, then you can go out once again. But if you don't have that, you need to go home. You need to stay home because it's better for you, because you won't be able to afford so many things. So if we talk about the pseudocode of the same thing, if if the money is less than $10, then go to home, or let's go out, count your money, and if your money still is greater than $10, then you can again go out the next day, obviously, or the same day, whatever you like to do. So yeah, that's the simple way of pseudocode and flowchart. So the second step is writing the program. If you have done the pseudocode, the flowchart, and all these things, you have done the planning, now it's the time to write the actual program. So if your analysis and planning have been thoroughly done, then translating the plan to program, it should be quick and easy task because you have already converted it into pseudocode, then it would be the easy part to turn it to codes. Then you need to document the program, because once you write all the program, you need to document all what you have done. You have to write that as well at every stage. So during the algorithm development program writing stage, explanation is very important. It's very important, and it's called documentation. Okay, so it helps user as well programming understand the exact process to be performed. And then comes testing part, where you have to test that the program must be syntax error free, it must be logical error free, it must be robust, it must be reliable. And then you have to do testing, different kind of testing. If you're running alpha testing, beta testing, if you have built an application, then you need to do unit testing, integrated testing, then system testing, these sort of things. And to get a broader view, we also need to understand that how much of effort is being spent on a real life program. Okay, so for that we need to compare the size of the program with the effort put in by the programmers. So that's again a very important thing, that the compiler for a language with a limited set instruction, full feature word processor. um, as you can see here, a military weapon management program could be several million lines. So we need to understand all those things. And in order to measure the cost or the effort spent on real life program, could be compared you know by the person per month, how much per month a person put in for particular software, or a person per year, or whatever. And you also need to design the web pages before you start building something. So the process goes like, first of all, you plan something. you know you plan about something that I'm building this thing, you gather all the requirements and all those sort of things. Then you create all the designing of the web pages, and also the high level system design, then low level system design. You learn about these terms in the upcoming lectures as well. Not in the upcoming lectures, but in your course. What is system design, what's low level and high level system design, these sort of things. And then you have to execute the code, then go on testing. After testing, you have to deploy, and after deploying, you have to do the evaluation, all those sort of things. So yeah, that's all for this lecture. Thank you very much, and keep learning. I would say that keep learning, keep practicing. If you're a computer science student, keep practicing. Practice is very important. Whatever you have learned, you need to use that in real life at the same time. So that's all. See you in the next one. Till then, keep learning and keep improving. Thank you.